Alrighty, it's time for everybody's favorite game show, solving inequalities. Let's start with graphing some pretty simple inequalities. Alright, so we've got x is greater than 3. Now the greater than, as opposed to greater than or equal to, those are two different things. We're going to want to represent those differently on our number line. Alright, so if it's greater than, strictly greater than, you're going to use an open circle. Okay, so an open circle like that. When it's greater than or equal to, you're going to use a closed circle. Okay, same goes here when it's less than or when it's less than or equal to. So the circle is the same for in between greater than and less than. All right, so there's our start. So we start with 3, so it's going to be open on the 3. I often like to draw it above, or you can always draw it on. I draw it above sometimes because you can see the line that I'm about to draw a little better, but why don't we draw it on? Okay. Now, to go greater than 3, what's nice and convenient is this arrow, this inequality here that looks like an arrow, actually points in the direction that you want to go. And a lot of times you'll see people do this. They'll draw it above, so that way you can actually see it, especially when you're drawing like on a black line with a pencil, it's hard to see. Okay, so that's how I'd represent x is greater than 3. Now for greater than or equal to, same idea, however. Now I'm going to have a closed circle on 3. That is closed. Alright, and then once again it'll be greater than, so it'll be going to the right. Now, when I said that the inequality points in the direction you're supposed to go, that's only true if your variable is on the left-hand side. Notice how all the variables are on the left-hand side. So whenever we solve, I like to put my x, or my variable, on the left-hand side. That way, these inequalities point in the direction I should go. Notice it's also pointing to the larger numbers. 4 is larger than 3, 5 is larger than 3, so on and so forth. Alright, let's keep it going. So open on the 3 for this one, because it's less than, not equal to. And then we're going to the left because it's less than. Alright, and then this one will be closed on the 3. And again, it's less than or equal to, so it's going to be going to the left. The equal to is taken care of by the closed circle, and then the less than is the arrow portion of it. Open is just the strictly less than, no equal to, and the less than points the arrow. Let us solve. So before it was already solved. It already had x. It was by itself. Now we actually have to solve. Well, this is the exact same thing as solving an equation, except for you got to deal with this inequality. And there's a couple little rules that we're going to have to deal with, and actually we're going to get to that over here on the second one. So first off, let's just go ahead and solve this one. Alrighty. So I'm going to subtract that 1, so I have 4x is greater than or equal to 4. Divide by 4. And now I have x is greater than or equal to 1. So this is just like the last one, except for now it's greater than or equal to 1. So when I graph that, open or close, guys? Great job. It is closed. Wow, you're awesome. Way to participate. And it's greater than, so it's going to the right. If you feel like you could probably try this one, go for it on your own. There is a sneaky little rule in this one that you might remember from Algebra 1. But feel free to pause, remember, at any time. That way you can always try the problem, then watch it. If you feel like you can do it, pause it, try it, then watch. So let us try this one. Alright, negative 7k plus 3k. If we combine those, we get negative 4k is greater than 16. Well, how do I get rid of the negative 4k? Some of you might be like, oh, I'll add 4 to the other side. Well, that's not quite right. What's happening here is it's negative 4 times k. So to undo times, undo multiplication, I divide by negative 4. Now here's the kicker. So I'm going to have k. 16 divided by negative 4 is negative 4. When I divide by a negative, what happens with the inequality? Oh, snap, it flips. If you divide or multiply by a negative, the inequality flips. Now we're ready to graph. It's an open on negative 4, and it's a less than, so we're going to the left. Very nice. Keep in mind that's our one rule change from solving equations. Everything's the same as equations, except if you divide or multiply by a negative, you flip the inequality. That's the only thing that's different. Alrighty, so here's what I suggest. Try these two problems on your own, and then check them. All right, if you're totally lost, you're like, I need to watch one more, then watch one more, then try the second one on your own. All right, let's do this. So first thing I'm going to do is I'm going to distribute this -2. And there are other ways of going about it, but that's what I'm going to do. -2x minus 18 plus 5 greater than or equal to 3. Now I'm going to combine like terms on that left-hand side, -2x, and then -18 plus 5. That's going to give me -13, greater than or equal to 3. Okay, on a roll. I want to get that -2x by itself, so to do that I'm going to add 13. And I'm going to have -2x is greater than or equal to 16. Nice. Okay. One more step. Divide by -2. Did I just divide by a negative? I sure did. So I'm going to have x is less than or equal to -8. I divided by a negative. Got to flip that sign. Yo. Or not sign. Excuse me. Inequality. Flip the inequality. Woo. Woo. All right, let's graph it on a number line. Here's what I like to do for number lines when I have to draw them out myself. I draw a line. I draw the 0. I draw my other number, which is -8. Those are my important ones. I like to put 0 as a reference point. And then I put my other number. Well, this one looks like it's going to be less than or equal to, so I have a closed circle. And it's less than or equal to, so it's going to the left. To the left, to the left. Like that Beyonce song. Okay. Cool. Hopefully that went well for you. Let's try this bottom one here. And again, if you didn't try the first one on your own, let's try this one on your own. Okay, here we go. Got to give myself some room. Cool. Okay, let's distribute again. A common mistake here. Did you do 7 minus 7 is 0 and just like have 0? Some people will do that. Or sometimes like if this is like a different number, people will tend to subtract these or add these first and then distribute. Don't do that. Don't fall into that trap. Alright, so we have 196 is greater than or equal to 7, and then -28x plus 49. Now I can combine my like terms. So -28x, and then 7 and 49 will give me 56. Cool. Okay, so here's what I'm going to do. And you don't have to do this. I'm going to get this guy over to the other side because I like to have my variable on the left. Okay? I like to have my variable on the left. That way, when I am graphing, the inequality points in the direction that I need to go. Cool? Alrighty, so let's do that. So I'm going to add that 28x. I'm going to have 28x on this side. I'm going to subtract the 196. And I get -140. Now I can divide all that by 28. And I get x is greater than or equal to -5. Now you might be like, wait, there's a negative. We divided. We got to switch it. No. We divided by a positive number. We were dividing a negative number. Dividing by and dividing are two different things. We divided by 28. We're dividing -140. So we're dividing by a positive here so the inequality stays. Now we can graph. 0, -5. Is it open or closed? Very good, it is closed. You guys are great. And then greater than, so it goes to the right. Woo! Okay, so this next one's soup's cool. It says, is the inequality always or never true? And basically what it's asking, this is kind of a special case inequality. Let's go about it solving the same way as we were before. So we'll distribute the -2. Then let's see here. We've got -6x minus 2 greater than -6x plus 7. So if I were to add 6x to both sides, these are going to basically cancel out, and I'm left with -2 is greater than 7. Is -2 greater than 7? No, that's not a true statement, so never true. Let's take a look at this next one here, and you'll see the difference between the two. Okay, so for this one, we'll distribute once again, and then we'll combine some like terms, and we'll notice something similar. 3x and 3x on each side. Well, if I subtract 3x, those are going to cancel out. I'm left with negative 15 is less than or equal to 8. Okay. Is negative 15 less than or equal to 8? Well, it is less than 8, so that is true, or always true. Woo! Always. So if you end up with an incorrect statement, if all your x's cancel out like it did up here, and you're left with a non-true statement, then it's never true. If all your x's cancel out and you're left with a true statement, then it's always true. Any number you plug in for x is going to work in this one. Any number you're going to plug in for x up here is not going to work. Some compound inequality time. So we're using and. 7 is less than 2x plus 1, and 3x is less than or equal to 18. Basically, guys, what we have here is like a 2-for-1 problem. Everybody loves a 2-for-1 special. You know what I'm saying? So we're going to solve that first one. The way I'm going to do that is you're going to have, well, I'm going to subtract 1 first. So I'm going to have 6 is less than 2x. Divide by 2, and I have 3 is less than x. All right. Let's leave that there for now. The next one, I'm going to divide by 3. So I'm going to be left with, if I divide by 3, x is less than or equal to 6. Nice. Okay. Well, there's a couple ways of writing this out. We can pretty much put these two together into one compound inequality. It'll look like this. Or we could write it out as an and statement. And what I'm going to do is I'm going to flip this guy around. So you're going to have x is greater than 3, and x is less than or equal to 6. Cool? Now if we were to graph this on a number line, here's my 0, here's my 3, here's my 6. Well, it's going to be open on the 3. It's going to be closed on the 6 because it's equal to. And you're going to be shaded between the two. Okay? So shading between those two. Because it's greater than 3, it's less than or equal to 6, it's between those two numbers. Now you can't have an and without an or problem. We got to have an or problem to go with it, you know, because they're like two peas in a pod. They're like peas and carrots, as Forrest Gump would have said. All right. So what is the solution of this bad boy? Once again, it's a 2-for-1 problem. We're just going to solve both. So let's start off by subtracting that 1. So we have 16 minus 1, would give me 15, is less than 5x. Divide by 5. I get 3 over on the left-hand side. It's less than x. Or you could write it as, x is greater than 3, kind of like we just had. All right. Other one. I'm going to have 3x is less than negative 3. So I subtracted that 9. Divide by 3. And I get x is less than negative 1. So I have x is greater than 3 or x is less than negative 1. I'm going to flip this one over here around so that way the x is on the left. Okay, so I have x is greater than 3 or x is less than negative 1. There's my answer. So let's graph it. My 0 down, my negative 1, my 3. Well, it's less than the negative 1. It's going to be open and going to the left. It's greater than 3, open and going to the right. And there's my graph for that awesome compound inequality when you have an or statement. Alright, we've got 2 more problems here. Feel free to pause it, try them. That way you can test yourself. And then you can always either scroll all the way to the end for the answer, or you can watch the whole thing. Or if you scroll through and you got it wrong, you can always scroll back and you can rewatch. These are videos. You can rewind. Alrighty. I'm going to change something right off the bat. We're going to make this 54 a positive 54, okay? So I'm going to change the problem because it will work out more how I want it to. Okay, so let's go ahead and solve the first one. Well, to do that, I'm a divided by 9. I want to multiply by 9 on both sides to solve that. Well, when I do that, I get a, and then 0 times 9 is just 0, so greater than 0. Or, now we got to solve the second one. I'm going to divide by negative 6. When I divide by a negative, it's going to be a is less than or equal to, and positive 54 divided by negative 6 gives me negative 9. Awesome. Alrighty. Let us graph. And this graph doesn't look like it's going to fit it that well. So I'm gonna do my own graph, okay? So I've got 0, I've got negative 9. Alright, when I do that, let's see here. Open on 0, because it's greater than, not equal to, and greater than goes to the right. And then a is less than or equal to negative 9, so I'm going to have a closed circle on the negative 9, and it's going to go to the left. Boom, graphed, awesome, America. Let's try the next one. Alright, to do this one, got to solve again. So I'm going to have k plus 7 is less than or equal to negative 1. So k, subtract 7, I get k is, actually I'll write it in a different spot. It's k is less than or equal to negative 8. And for this one, I add 8. So I have k is greater than negative 7. Oop, can't really see that. All right. Cool. So let's graph it. Again, oh great, doesn't fit on the graph. I'll draw my own. I can handle that. We have our 0, our negative 7, and our negative 8. Well, on the negative 8, it's less than or equal to, so it's going to be closed and less than. The negative 7, it's strictly greater than, so it's open and goes to the right. Nice. Words and math. It's just so much fun, and I know you guys love it. You know, you love to be frustrated by it. You're like, why are there words and math? This is not English class. Well, too bad. Deal with it. All right. The sum of a number and 5 is less than negative 7. Ho, 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 ho. Well, sum means addition, adding a number and 5. We'll say the number is n. So sum of n and 5, n plus 5. It says that it's less than negative 7. Less than negative 7. Yay! That's all we have to do. It's not even asking us to solve it. It's just saying write the inequality from the sentences. We're done with that one. Try the next two on your own, and then hit play when you're ready. Alrighty, 5 fewer than a number is at least 12. Okay, so 5 fewer, that's like subtraction. So a number minus 5, so we're talking 5 fewer than the number, is at least 12, meaning it's 12 or more. 12 or more, it's greater than or equal to 12. It's got to be at least 12, so it could be 12, or it could be more than 12. There we go. So at least means greater than or equal to. And lastly, the quotient of a number in 3 is no more than 15, meaning it could be 15, but it can't go above that. So 15 or less, like less than or equal to. There we go. There's our inequality. All right. Quotient of a number in 3. Quotient means division. So n divided by 3 is less than or equal to 15. The quotient of a number in 3 is no more than 15. Whew. That's a lot of stuff with inequalities in this one. But you guys are rock stars. You handled it quite well. Very proud of you. Now try some problems from the book because they're awesome.